Interpretation of clean Jordan equation. Now, in non-relativistic case, first of all we will say the probability and probability density in non-relativistic case. In non-relativistic case, probability, position probability, okay, position probability, density P of RT is defined as mod of psi of RT whole square, means P of RT is equal to mod of psi of RT mod square. Okay, now psi star of RT, and it means psi star of RT into psi of RT. Okay, now the next, in non-relativistic case, the probability density is probability current density is which is given by J of RT is J of RT is equal to H cross by 2m psi del psi star minus psi star del psi. Now that probability density J of RT satisfy the equation of continuity. So that equation of continuity is invariant under the Lorentz transformation. Therefore, it is reasonable to expect the same continuity relation to validate relativistic case. Now, means really the continuity, we all know the continuity equation del by del t P of RT plus del dot J of RT is equal to 0. That continuity equation is invariant in Lorentz transformation. So similar equation we can use in relativistic case. So in depth now, first of all, clean Jordan equation, right? Clean Jordan equation minus h cross square del square psi of RT by del t square is equal to minus c square h cross square del square of psi of RT plus m square c power 4 psi of RT. This is clean Jordan equation. Now pre-multiply that equation number 1, pre-multiply equation 1 with, not 1, that one is first one, that one is second one, and that equation is third, it's fourth one. Okay, multiplying equation 4 with pre-multiply psi star of RT will get minus h cross square psi star of RT del square psi of RT by del t square. Next, equal to minus 3 square h cross square psi star of RT del square psi of RT. Now m square c power 4 is a constant, so psi star of RT into psi of RT. Okay, now if we take the complex conjugate of that equation number 4, what is the complex conjugate? Del minus h cross square del square psi star of RT by del t square. Okay, psi becomes a psi star and I turns into minus I. So here there is no any imaginary term, so we convert only psi into psi star. Minus c square h cross square del square psi star of RT plus m square c power 4 psi star of RT. Now that one equation number 5. Okay, pre-multiplying, this is equation number 6. Pre-multiplying equation 6 with psi of RT. Psi of RT. Pre-multiply that equation 6 with psi of RT. First, minus h cross square psi of RT del square by del t square psi star of RT is equal to minus c square h cross square psi of RT del square psi star of RT plus m square c power 4 psi of RT into psi star of RT. Okay, now that equation number 7. Now subtract equation number 7 from 6 not 6, 5. Okay, what is equation number 5? H cross square psi star del square by del t square psi. Equation number 6. Okay, that one equal to minus c square h cross square psi star del square psi of RT plus m square c power 4 psi star of RT into psi of RT. Okay, now equation number 7. Minus h cross square psi of RT del square by del t square psi star of RT is equal to c square h cross square psi del square psi star of RT plus m square c power 4 psi star of RT into psi of RT to psi star of RT. Okay, now we are subtracting that equation. First common out minus h cross square, then psi star del square psi of RT del t square plus we common out minus turns plus. Okay, so if we common out minus h cross square, we will get here negative sign. Okay, psi del square psi by del t square. Okay. Next, minus become plus and minus here. That will, because sin to psi star is probability density and probability density is constant. So next one is minus h cross square c square, common out minus h cross square c square, then psi star del square psi minus what psi del square psi. Okay, then minus h cross square get cancelled. Only remaining term c square psi star del square psi minus psi del square psi star. Okay, here psi star del square psi by del t square minus psi del square psi upon del t square. Okay, remember up to that. Now first of all, that equation that our equation del square psi upon del t square minus psi del square psi upon del t square. Okay, here star is there. Next, equal to c square psi star del square psi minus psi del square psi star. Okay, now look at that equation. If we common on del by del t, what will get? Psi star del square psi upon del t psi del star by del t is equal to c square. मैं आपको दिखाती हूँ कैसे प्रीवियस स्टेप मिलती है हमें इससे. ओके, psi star del psi minus del साई स्टार. ओके, फर्स्ट ऑफ ऑल देखो, अगर हमने डिफ्रेंशिएट किया डेल साई स्टार, डिफ्रेंशिएट करो यू इंटू वी लगाना डेल साई अपन डेल टी. ओके, प्लस साई स्टार del square psi upon del t square. Okay, again if you differentiate, again apply here uv. Okay, del psi upon del t, del psi psi star upon del t. Okay, next minus psi del square psi star upon del t square. Del t square. Okay, equal to c square. Again that side RHS, differentiate del psi star del psi plus psi star del square psi minus del psi star minus what psi del square psi star. Okay, if we that term get cancelled. Okay, again here that term will get cancelled. After that we'll get that previous equation. So we can write that equation as this: del by del t psi star del square psi upon del t square minus oh sorry here square is not there, psi del psi star by del t square is equal to c square del what psi star del psi minus psi del psi star. Okay, after now after that this is if you first first look at here, that one, j of rt is IH cross by 2m. So multiply IH cross by 2m on both sides. IH cross by 2m. Okay, then IH cross by 2m. Then if IH cross by 2m del psi del dot psi star del psi minus psi del psi star. Okay, that whole term is j of rt. This is j of rt, means probability current density. So we can write that c square is write that c square on left hand side, means IH cross by 2mc square del by del t, as write that term as it is. Then it will become del dot j of rt, but minus del dot j of rt. Okay, minus del dot j of rt, because here first term is psi del psi star. Okay, so if we common out the negative sign, we will get minus del dot j of rt. Next one, the term is p of rt is equal to IH cross by 2mc square psi star del psi upon del t minus psi del psi star upon del t. That one is p of rt. If we write p of rt here, that whole term become p of rt. Then del by del t, p of rt is equal to minus del dot j of rt. Okay, if we take right the term on left hand side, del by del t, p of rt plus del dot j of rt is equal to 0. This is equation of continuity, which is invariant in under the Lorentz transformation. Okay, now we investigate that P of RT in detail. If psi is real, P of RT vanishes. When psi is complex, to get better relation, that equation is written as P of RT. First, P multiply IH cross inside, okay? Then psi star to MC square. Psi star, sorry, here only one is there, okay? Psi star IH cross del by del T psi minus psi IH cross del by del T psi star. Okay, that is energy operator, that is E. Okay, then 1 upon 2 MC square psi star. Wait a minute. Here we need negative sign. Okay, here also we need negative sign. No. Wait. Here minus I square because it is a complex conjugate one. So we need here negative sign, means psi star E psi plus psi E psi star. Okay. Then E is a constant. So psi into psi star E divided by 2 MC square. Okay. Then E is a constant term. Then psi star plus psi into psi into psi star. This is probability density. 1 plus 1 2 2 E mod of psi square. Okay, 2 MC square. 2 get cancel, means E by MC square mod of psi square. Okay, this is the P of RT. So the from that equation we can conclude that when P is positive, E is positive, and when P is negative, E is also negative. Means the probability density takes both positive as well as negative values.